Think about our digital world for a second. It's this huge, invisible battlefield where a war is being fought every single moment. Not with tanks and soldiers, but with data and code. With just trillions of digital interactions happening all the time, how in the world do you find the hidden threats that are lurking in all that noise?
And that really gets to the heart of the problem, right? It is the ultimate needle in a haystack situation. We're creating more data than ever before, so how can anyone possibly find that one tiny clue, that one quiet signal that screams, hey, there's a cyber attack happening right now?
So, how do you tackle this? Well, the answer is a little counterintuitive. Instead of trying to make the haystack smaller, cybersecurity experts realized they needed to build a much, much bigger one, but with a really clever plan. So, what's the first step? You collect, well, everything. And I mean everything. We're talking network traffic, system logs, every single login attempt, every alert. The thinking here is that more data doesn't just create more noise, it creates more context. And that context is absolutely crucial for security. But why on earth would you gather all this data? It's all about becoming a kind of digital detective. The goal is to spot attacks, sure, but also to find weird behaviors, to understand what's normal, to investigate when things go wrong, and just to make sure everyone is playing by the rules. Okay, so we get why we need the data, but how do you make any sense of it all? That is where a seriously powerful tool called data mining comes into play. So let's dig into what that actually is. At its core, data mining is basically a team-up of two awesome things: powerful databases that can store and find massive amounts of information, and really smart machine learning algorithms that can learn from all that info. It's all about turning raw data into useful knowledge and then turning that knowledge into better, faster decisions. And this whole process really boils down to two key missions: prediction and discovery. Let's break down exactly what that means. So prediction is all about looking into the crystal ball, you know? It uses data from the past to make an educated guess about what's going to happen next, like flagging a weird credit card charge before it goes through. Knowledge discovery, on the other hand, is about understanding what's happening right now. It's like turning on the lights in a dark room to find hidden patterns you didn't even know you should be looking for, like a brand new type of cyber attack. All right, so we've got the why and the what down. Now let's get into the how. How does something as simple as a single login attempt transform into a critical piece of security intelligence? So here's that journey in action. It all kicks off with that raw data, your network traffic, system logs, all of it. But you can't just dump it into some algorithm. Nope. First, it has to be collected, cleaned up, and organized so it's ready for analysis. It's kind of like cooking. You have to prep your ingredients first. Only then can the data mining techniques get to work, spotting threats we already know about, and, even more importantly, discovering brand new ones we've never seen before. And, this whole thing points to a really critical shift in thinking. This isn't like a firewall that you just set up and forget about. The threats out there are changing all the time, so our defenses have to evolve right there with them. We have to move from just reacting to problems to proactively predicting them. Security has become a continuous learning process. And that's the magic right there. It's this constant, never-ending loop. You start with a problem, you explore the data, and you build a model. But the real key is that you are always gathering feedback. Every new piece of data that comes in helps the system get just a little bit smarter, creating this beautiful, continuous cycle of improvement. Okay, this whole continuous learning loop idea sounds cool, but what does it actually look like? Let's bring this down to earth with a real-world example I'm pretty sure we've all worried about at some point: stopping credit card fraud. So picture this: you're a bank. You have millions of transactions flying through your system every single second. You have to instantly catch the fraudulent ones, from stolen cards, online scams, you name it. But here's the catch: you have to do it without accidentally blocking your real customers' legitimate purchases. It's an incredibly high-stakes balancing act that happens in a blink of an eye. So how do they pull it off? The secret sauce is a data mining model. This thing is trained on an insane amount of past transactions, both good and bad. It learns your personal spending DNA, where you normally shop, how much you usually spend, what time of day you buy things. It literally builds a profile of what's normal for you. And then for every new transaction that comes in, it asks one simple question: hey, does this fit the pattern? And this is where it all comes together. Just look at this. You've got your normal, everyday stuff, low risk, no problem. But then, whoa, look at that one. A $10,000 purchase from Canada.
For a user who has never, ever done that before, the model just screams, "This is not normal." It flags it as extremely high risk, and bam, the system blocks it instantly. The user's protected before any money is even lost.
And what's so cool is that fraud detection is just one piece of the puzzle. Let's zoom out for a second and look at the massive idea that powers all of this. It's something called the Janus principle, named after that old Roman god with two faces. One face looks to the past, the other to the future. And that's exactly what data mining is doing here. We study the past to get a grip on the present, and by understanding the present, we can start to predict and defend against the future. And that leaves us with a pretty wild thought to chew on, doesn't it? We've seen how our digital past holds the keys to our digital future. So as we keep collecting more and more of this data, every click, every login, every single transaction, and as our tools for analyzing it get exponentially smarter, how much of our future can we really predict? And what does it even mean to be truly protected in a world where the threats of tomorrow might already be written in the data of today?